Jai Hind, myself Pushkal Kumar Shukla, Assistant Professor in Computer Science Department at Akgec Engineering College, Ghaziabad. Today I will teach NFA and DFA in Automata theory of Automata in formal language, and this topic is helpful to the BTech 4th semester students and also those students who are preparing for PSUs, GATE, etc. So NFA and DFA. So NFA and DFA. What is NFA? Now the question is, what is NFA? So in NFA, as the name suggests, non-deterministic finite automata is a machine. It is a machine can move from a present state to a combination of states. For a given state and the given input, if it goes to the combination of states, more than one states. So that's why we say it is non-deterministic. But in a case of DFA, what we see, for a particular state and a particular input, it goes to the fixed state. But in a case of non-deterministic finite automata, for a particular state and a particular input, it goes to the combination of states. Here we see here, for a particular state Q0 and a particular input A, it goes to the Q1 and it also goes to the Q2. So the state is, next state is not fixed. So this type of situation is called non-deterministic. As number of states and the number of input letters on the input tape is finite. That's why it is called finite automata. And as a whole, non-deterministic finite automata. It means number of states, finite means number of states on that is Q0, Q1, Q2, that is Q1 is a finite, and number of input letters on the input alphabet, that is also finite. And also the machine non-deterministic, for a particular state and a particular input it goes to the combination of states like this. So all these things are there, so that's why it is called a non-deterministic finite automata, non-deterministic. While in case of a deterministic finite automata, number of states and number of input symbols on the input tape, that is finite, but for a particular state and a particular current input, it goes to the fixed state. So that is deterministic case. That's why it is called a deterministic finite automata. So this is the basic difference between the DFA and the NFA. Formal definition of NFA. So mathematically, NFA is defined as a 5 tuples, same as in a DFA, and these 5 tuples are M equal to Q, this, Q0 and F, that is finite set of states, that is input alphabet, finite set of input alphabets. This is a delta, is a transition function, and there is a difference between the transition function. There is a difference in transition function of a DFA and NFA. We will see here. Then this is the initial state and this is the final state. So Q is a non-empty finite set of states, input alphabets, that is sigma, and transition function is a mapping from, there is a difference in DFA and NFA. So transition function mapping from Q to sigma to 2 k power Q in case of NFA. And in a case of DFA, transition function is a mapping from Q to this to Q. Here 2 k power Q. So we see here there is a difference, 2k power q and this is q. And q naught is the initial state and AF is a set of final states, yeah, accepting states, that is F is a subset of q. Non-deterministic finite automata, that is NFA, alphabet A, see here through the example. So, starting state is q naught because arrow is marked here at this state. If two choices are there, automation will go either this path, yeah, automation will follow this path. If automation will follow, two choices are there. So, if automation will follow q naught and initially the reading head, yeah, reading head will be at leftmost position of the input symbol, input tape of the input symbol. So, initially the reading head will be there, so leftmost position. And finite control machine will be at the q naught state, initial state. After scanning this, reading this A, the finite control machine which controls the states will reach at the Q1 state. Again, reading head will be read this A, this is A, and it goes to the final state. This is the final state. Yani, it means this automation, yeah, this NFA will accept what language? That is AA. This automation, yeah, this NFA will accept a string AA. Accept this because from the initial state, after scanning, yeah, reading the input symbols from the input tape one by one from left to right, it moves to the final state. So, AA is going to accept by this NFA. For this NFA, two choices are there. If it follows this path, initially Q naught, and it follow this Q. So, it is not the final state. So, no transition, the automation hangs. Here we see it goes to the final state. So, automation will accept the particular language, that is particular string AA. But if there is another path and it goes to the from Q naught, after reading A, the automation goes to the Q3 and this is the intermediate state, not a final state. So, no transition is going to take place and this automation going to hang. The automation hangs. Input cannot be consumed. So, therefore, input cannot be consumed. An NFA accepts a string. An NFA accepts a string. When there is a computations of the NFA that accepts the string. In a previous example, we see computation of the NFA. When there is a computation of the NFA that accepts the string, in that case, the A's string is accepted. There is a computation, all the inputs is consumed and the automation is an accepting state. So, in a previous example, we see all the inputs are consumed, AA was consumed and it lastly gone to the final state. So, we say this input is going to accept by this automation. So, A is accepted by the NFA. So, here we see AA, here we see A is accept because this computation accepts A, but here see this A is not accepted, this reject actually. And NFA rejects a string where there is no computation of the NFA that accepts the string. Yeah, for each computation, all the input is consumed and the automation is in the non-final state. Those two situations are there for not accepting, rejecting the string, when there is no computation of the NFA that accepts the string. For each computation, all the input is consumed and the automation is not in the final state. The input cannot be consumed. Two situations are there. For example, A is rejected by the NFA by this only simple if you are talking A. So, by this way start from this Q0, this and Q1 and it does not go to the final state. So, by this way this is a reject, and if it follow the path this, then Q3 again goes and it is an intermediate state, not a final state. So, by if follow path this, then it is also a reject. Another example, rejection examples. Start from the Q0, is two paths are there, two choices are there, either go this, either go this. So, read input A here, it goes to the Q1, again read A, so reading head will be here A, it goes to the Q2 and this is the final state. But here we see here all the inputs are not going to consumed here, no transition, the automation hangs actually. So, either all the inputs is consumed and reach to the final state. So, here we see it reaches to the final state, but all the inputs is not going to consumed. So, no transition, the automation hangs actually. This is reject actually, and input cannot be consumed. Again in second choice we see here start from the Q0 and if it scans A, then it goes to the Q3 state phase and hangs because it is not a final state and inputs are also, or not all inputs are consumed actually. So, no transition, the automation hangs. Input cannot be consumed. AAA is rejected by the NFA. Lambda transition. In NFA, lambda transitions are also possible, but in a DFA not possible. Lambda transition, epsilon transition should not there, but in a NFA lambda transitions are there. So, Q0 taking input A goes to the Q1, then Q1 state lambda transitions are there, here lambda transitions are there. After taking lambda transition it goes to the Q2 and for Q2 taking input as A goes to the Q3. So, this is only possible in NFA, non-deterministic finite automata, lambda transition, epsilon transition, but in DFA and NFA not. So, how? Start from the state Q0, reading A, it goes to the Q1. Read head does not move. In this case, if lambda transitions are there, reading head does not move, only state is going to change. So, reading head will be at the same position A and it goes to the next state, that is Q2, lambda transition, and then after Q2, after reading A, it goes to the Q3 state. So, this after Q2 the reading head will be at this position. For this, Q naught A goes to the Q1, then lambda, no input symbol is going to scant, only state is going to change Q2, then Q2A, then it goes to the Q3. So, no transition, the automation hangs. So, what is the difference between the DFA and NFA? DFA and NFA. Very important. This is DFA and this is NFA. The transition from a state is to a single particular next state for each input symbol, hence it is called deterministic. The transition is going from a particular state and a particular input, it goes to the particular next state. That is why it is a deterministic. But in a case of NFA, the transition from a state can be a combination of states for each input symbol, hence it is called non-deterministic. In case of transition, epsilon transition or lambda transition is not allowed in DFA. This type of transition is not allowed. But in case of NFA, epsilon or lambda transition is possible, is permitted. DFA takes more space. DFA takes a more space, while NFA takes less space. We see in future by example. DFA is as powerful as NFA, and NFA is as powerful as, but both having the same capability, DFA and NFA, both having the same capabilities. DFA is as powerful as NFA and NFA is as powerful as NFA, but DFA takes a more space as compared to the NFA. A string is accepted by a DFA if it transits to a final state. A string is accepted by a DFA if it transits to the final state. And a string is accepted by a NDFA if at least one of the possible transition ends in a final state. Any one of the possible transition, all different transitions are there, possible transitions are there, and any one of them ends in a final state accepted by NDFA if at least one of them ends in a final state. But in the case of this, a string is accepted by a DFA if it transits through final state. And lastly, every DFA is NFA, but every NFA is not DFA. So, every DFA is NFA, but every NFA is not DFA. So, what we do? We convert NFA into DFA. Yeah, we convert epsilon NFA into NFA, then NFA to DFA. So, many times the question is being asked to convert this epsilon NFA into first NFA and then NFA into the DFA and then minimize the DFA. That is most important question frequently asked in the AKTU examination. Thank you.